Welcome everyone. Thanks for joining us today to this workshop. I may apologize the participation of Ana Maria Valeri, the coordinator of the project, as she's feeling unwell today. And I will be running the intro of the project. So I'm gonna jump directly to it. So this is just an initial slide for introducing the history of the positive energy buildings. As you know, Culturally is a European-funded project dedicated to define, demonstrate, and test approaches for building and demonstrating positive energy buildings. Since 1994, that the first building was designed, the Heliotrop in Freiburg in Germany. Many progress has gone on the direction of reaching positive energy balance throughout the built environment. We have another example in 2005 when the first neighbor that was sharing electricity production and flexibility assets among the different buildings was built. Then we jump to the 2010 when the APDB launched the concept of nearly zero energy buildings, which is a step forward on the design and construction of high efficient buildings in Europe. And then we jump to 2015 when our first multifamily and multi-storage building was built in Frankfurt, Germany, with successful rates of positive energy balance, including all the different uses within the building. Now we are in 2021 with several projects that are currently running on the topic as Culturally, but others are Sinikia or Excess are also working on demonstrating and testing the positive energy concept, as well as defining this. As you may have received some news potentially from the project in the previous months, we ran it a workshop and also worked together the three projects to discuss and bring together a definition of the project. But in parallel, the different project has been working on their own definitions, as not all the point has been agreed among the different approaches. Also, it's worthwhile to comment that in 2026 we expect a new EPDB where the plus energy building concept is expected to be incorporated, and this may allow to a further uptake of the positive energy concept all around Europe. So the starting by first slides on the definition of the positive energy building from the perspective of Culturally. These three aspects are key for us. One is the reduction of the greenhouse gas emissions in the system surrounding the building, but also incorporating neighbor and district scale, as the positive energy building intends to support this flexibility concept by reducing the stress in the energy grid and allow the exchange between the different buildings. All this may help the transition to a zero energy state and cost-efficient approach. As well, plus energy building targets focus on the life cycle, the indoor environment, and the e-mobility, by means that we aim to reach low carbon emissions to make the indoor environment accessible, comfortable, and healthy, and allow that the building features may incorporate an easy access to e-mobility. The overall objective of the project is to define viable and testable technology concept and business cases for positive energy buildings by accounting for climate and cultural approach that encompass over the overall building configurations, technology, and as well user and system interaction. The Culturally is developing a set of solutions that will be comprehensive and easy replicable, thanks to reliable methods and practical guidelines that are going to be developed during the project, thanks to the demonstrations in the 4 climates. As key expected impacts that the project will bring after the 5 years of implementations, we expect to support the near zero energy building concept and go forward from this by taking into account the cost efficiency and keeping similar cost in comparison to the near zero energy buildings, as well to contribute to the reduction of CO2 emissions in the residential sector by 2050, with an increase of 80% compared to the levels in 1990s. 1990. As well, the improved indoor environmental quality might be a key asset to be provided through the demonstrations and the user satisfaction that will be measured through post-occupancy dedicated campaigns that will run in the 4 different climates to secure and validate the design. And this will support the increase of the share of plus energy houses and buildings in the market by 2030. The overall approach of the methodology incorporates several phases. First one is part of the work we are doing in this workshop is related to the mapping of climate and cultural geoclusters in the 4 different climates, where the key technology developments will be tested. And the definition of the solution sets for each geocluster will be led thanks to the mapping exercises and the technology developments that will be incorporated into the 4 demo cases in the 4 climates. In the next slide, I will go deeper on these 4 demos. With the final scope of decarbonizing the European building stock and increase the share of plus energy houses. This slide shows the 4 demonstrations that we are running currently. The 4 of them are in a different typology of building, by means that the ownership model is different, and as well the functions and the uses of buildings are slightly different in each one. Even if, of course, we are focusing on residential in the residential field, and all of them are incorporating residential approaches. So the first one I'm going to mention is the one in France, which is owned by Vilogia, and this will be a private social housing, which is slightly similar to the Italian one in terms that will be a multi-storage building with only residential uses expected. The difference between these 2 is that the first one is dedicated to social housing, and the second one is in the free market. Then the users will be the cluster of user will be different in each one. Then we have the one in continental climate in Lisgen, Germany, which will have two different uses. One in the bottom floor, which will deal with offices, and the upper floor will be apartments for normal selling. And the one in subarctic climate, which is in Bærum, Norway, close to Oslo, which is a assisted living building that also have some spaces in the building for workers. We are now in focus, and this workshop will be focusing the objective 1 of the project that intends to define cultural peculiarities impacting building energy balance. And the mapping exercise and the atlas is part of this objective. And just a brief slide that comment the basis or the first step that we analyzed it in order to include and integrate the concept of the atlas, as we identified the differences that exist in energy practices and energy consumption all around Europe. And this slide is showing these different by two opposite countries in terms of climate, Finland and Italy, where the practices are slightly different, and this may affect the energy balance calculations that are part of the concept, by means that some activities have a higher intensity and a bigger percentage, a different percentage of uses, and this might take into account in order to incorporate the real needs and expectations from users. As for instance, the cooking is quite significant. The difference is from 1% to 6%, but also others are suffering minor changes that need to be accounted, as the energy produced is limited, and this limitation need to be transferred to the practices that users do in their daily life. So thank you for this presentation. Now I'm gonna just go briefly through the agenda of the workshop and initiate with the following sessions. Gloria is gonna share the agenda. So we are now about to start the two-cup energy atlas in a nutshell that will go through the different contents and the background and the initial concept that has led the design of the two-cup energy atlas. Then Juan Camilo Mahecha will be presenting his paper on towards integrating occupant behavior modeling in simulation-aided building design. And Lorenza Pistore from University Ca' Foscari will be introducing their research on indoor environmental quality aspect for positive energy buildings. We will have a coffee break of 10 minutes for resting and getting ready for the next interactive activity that will start at 11. Where we will propose a few exploration activities, exercises with the participants by using the atlas. And after these 20 minutes, we will have a brief description of the experience of the Mediterranean demo case of Culturali in Italy, run by Cristian and Riccardo from EURAC. And after this, we will have the last part of the workshop where we will have the chance of debate and discuss the concept and approaches that has been developed in the project, and listen and collect your feedbacks. finally, we'll have a wrap-up and conclusions of the discussions in the last 5 minutes, and we will close the workshop. So we are going to start by the first presentation, which focus on the Atlas. Okay, so here a brief outline of this presentation that will start by commenting the key concept that has guide us to run this design and this tool. Then we will go through the key features that are part of the Atlas and the key concept, and finally we will explore the Atlas layer by layer, commenting the different contents and results that we are transposing into the GIS map. So just for briefing how the Atlas is aligned with the definition that has been commented in the previous presentation, the Atlas has a strong alignment with the concept of viable and tireable concept of plus energy buildings, by means that we understand that each positive energy building needs to be properly tailored to the specific context and users cluster that is going to occupy the building in order to reach successful outcomes from the design and to reduce the gap between design and real performance. The Atlas is supporting the facts of the provision of user-related energy consumption, also from the operation part as well, but we intend to focus on users, and as we believe that having them together and integrate them into the principles of the design may enable these successful outcomes. As well, the information that is provided in the workshop intends to support a good dynamic matching as we analyze and study the different uses and practices which need to be incorporated into the dynamic matching calculations for matching both vectors, load and generation. As well, it will it aims to support the predictions aspect by means that we are providing a specific layer that bring occupant behavior models and potentially how this can be integrated into the simulation exercise, or at least to source valuable research studies that can support that process there. As well, we will host measure data on the final energy and other monitoring data that will be conducted in the 4 demos. And the Atlas is adding value to the building flexibility concept by providing interesting assets that can be incorporated into the flexible analysis of the building. In addition, it will provide value to users by means of accessing, providing accessible, comfortable, and healthy indoor environmental concept for being incorporated into the design. Initially, the Atlas was based, and the first studies we ran into the project focus on social sciences, and we deliver first deliverables into the project, into the work package related to cultural and climate variables that are referring to these approaches, and has drive the current configuration of the atlas. But this has been complemented with further investigations that has been developing in the first 2 years of the project, and now we can pose the following 2 questions that somehow give an answer to the conflicts that have arisen between the different approaches. So how to tackle user energy demand by means of integrating its complexity into PV design? We know that user behavior predictions and simulation-aided building design could conflict with energy demand, with the energy demand concept from a social sciences perspective, by means that the consciousness of users and the individual behavior is driven by socio-cultural factors that potentially will not be captured from the data monitor and the time use schedules that are used for the predictions. But instead, both approaches become complementary and may drive some light on the integrations of user and energy related practice into the design. With the aims to transfer the sociocultural and climatic factors that directly affect building energy performance into the atlas, specific layers has been designed, and I'm just mentioning here the last 3 developments that are referring to the energy cultures drivers that describe users' energy practices, intensity and consumption value variables, as well as technology selection and so on, in order to tackle the social sciences approaches. And this is complemented with the occupant behavior models that bring and source a huge number of publications and scientific papers referring to modeling the occupant behavior for different actions and presence scope. And this is also complemented through the indoor environmental quality aspect layer group, and that bring operational temperatures estimations for the different climates that Lorenza is going to be presenting later on. The following two sentences that quotes that I'm including here intends to strengthen the concept that human behavior is key in order to get accurate simulation results and as well the predictions of the energy consumption. And this is commented in most of the papers that refer to these novel approaches for simulation and modeling. As well, it is important to highlight that occupants a priori might not be represented as the main culprits and responsible for the energy performance gap. This is not properly evidence-based demonstrated throughout the full review of literature on the topic, but instead it is stated that user could become partners in a collective endeavor to enhance the energy performance of the built environment. And this is the approach that we are trying to pursue in Culturally. So passing through the main features and the main concepts that define the atlas. we intend that the atlas is perceived as a comprehensive set of information sources which add questions and provide key inputs into the build designers' daily practices. It's backed up on a GIS online interface that make available the results from Culturally project and other external sources that complement and support the process. This is divided in two main group of layers. The first one are statistical data referring to energy, socioeconomic, climatic, and environmental aspects. Most of them provided in a numerical format. And the PEB design criteria drivers group group the different layers that have a more text and conceptual approach together with graphics. So we bring PEV case studies, guidelines, also local policies and boundary conditions, and the energy culture group. This is the kind of information that can be reached and is sourced throughout the energy cultures layer group, where we have schedules and charts regarding windows opening, all the distribution of the user activities in the different journeys in different locations, different attitudes of user regarding lighting, shading, or clothing, as well as the thermal preferences for operative temperatures and interaction with thermostats and so on. So now we are going to explore the atlas. And this is going to be just few minutes before I give room to Juan for doing his presentation. So we have up to now 8 different groups of layers. The first one is referring to household energy demand, which provide information in the different for different uses: space heating, space cooling, water heating, cooking and lighting, and appliances distributed at national level, NUTS 2, and the sort of information that is provided allows, just 1 second, that I have turned on this one. Where in each one of the different uses, it is highlighted the percentage of which represent that equipment or that practice into the domestic level, and this may help understanding the differences among the different countries and how users may interact and may have an impact on the final energy consumption. As well, we have the socio-economical group of layers that incorporate some factors that combined with other layers may bring interesting insights, as the population density, as well the disposable income by the Gini coefficient, and this may be helpful for policy development at an energy level. Also, we are including layers referring to pricing for the different energy vectors, energy sources. Then we have...
interrupt you, but we are 11 minutes late, so if you could please speed up a little bit this part, maybe.
Yes, I'm gonna just end it in few minutes. So climatic factors, we have here granularity until NUTS 2 level for the cooling and heating degree days. which help to locate the buildings and the projects into more accurate positions at the European level. As well, we have the indoor environmental quality aspect that Lorenza is going to comment later on. The group referring to the demo cases, that is a georeference layer which bring information referring to the 4 demos. And this is going to be updated according to the last developments from each demo that incorporate the selection of technologies and so on. Also, we have the PV guidelines referring to the 4 different climates, policy, local policies and boundary conditions, which incorporate a specific report on these aspects for the 4 climates, and finally the energy cultures layer that have the group layer that have the social sciences approaches and the occupant behavior modeling. And this last one is also providing information and nudge to level for the available regions. And this bring you to the different papers and that has been identified and are coming from the Annex 79 related database, which has a broader spectrum of analysis at world level. So this is a brief introduction of the NATs, and now I give the room to Juan to be going deeper on how we can integrate user behavior into the simulation aided design. Thanks.
Thank you, Ivan. I'm going to share my screen. So good morning, everyone. I'm Juan Mahecha. I'm a PhD student at the Politecnico Milano and with EURAC research. And today I'm going to talk about occupant behavior modeling, building performance simulations. The agenda for today is some context, motivations, objectives. What is the occupant behavior research field? What are the main research gaps? And some insights about integrating occupant behavior modeling. Finally, some conclusions. So first, well, this talk is related to a review article that we published late last year in Energy and Buildings. It's titled Towards Integrating Occupant Behavior Modeling in Simulation-Aided Building Design, Reasons, Challenges, and Solutions, together with Ulrich Filippi from EURAC as well, and Graziano Salvalai from the Politecnico Milano. Then the rest of the presentation is going to be a snapshot and some highlights from the paper that you can access, is open access. So what is the motivation here? Well, the building performance gap. So many times we have a difference between what we are predicting with simulations, building performance simulations, and what we are actually measuring in reality. And the literature shows that this difference could be even as high as 4 times what you measured and what you predicted. There are 3 main causes of this, not only these ones, but these are acknowledged as the main ones, and could be differences between what you design and you put in the simulation versus as built, so difference in technical specifications of building systems or faulty building systems, for example. Also differences between the climate data that you are introducing in your building simulation and the actual microclimate that could be influencing the performance of the building. And then also occupant behavior in 2 aspects, like we are addressing the uncertainty of occupant behaviors because maybe we don't we lack of knowledge at certain stages of the building life cycle. For example, if you are designing a building at early stage, you may not know which are the final use of some spaces in the building, and then you cannot really represent well the occupant behavior. Also because we usually rely on standards and standard schedules and occupant-related power densities to represent the occupant behavior. And this approach is going to neglect the diversity of the occupants and the stochasticity of the occupants. And because of this, we reviewed the literature asking what is the added value of considering more advanced occupant behavior models? How can I choose the appropriate occupant behavior modeling approach, and how can be this integrated? So let's start talking a little bit about the occupant behavior research field that goes around the human building interaction research loop, where we have a first stage of investigation. Here we are using data collection and monitoring campaigns to gather information about the occupants, their features, characteristics, and how they interact with the building. So here we advance also in sensitive technologies, privacy and ethic issues. And then with this information, we move to another stage, understanding, when we actually implement analytical and modeling methods in order to understand the occupant behavior. Which are the drivers motivating the occupant behavior, which are the difference of these drivers in different contexts. Then we understand also that occupant behavior is influenced not only by environmental and time-related issues, but also contextual, physiological, psychological, social, cultural. So it's a really complex phenomenon with so many things behind. And then we can classify the occupant behavior in presence, when the people is or not in the building, an adaptive behavior that is intended to adapt the indoor environment. So for example, I'm feeling hot, then I open a window. Or non-adaptive behaviors that are more related to the kind of activities that the users are performing in a building. For example, watching television. And then nowadays we have more than 300 models published in the literature, from statistical, probabilistic, agent-based models. And then with these models, we can start like improving our building performance simulations, integrating the models with tools, for example, as co-simulation, implementing occupant-centric design and operation, and implementing different design strategies such as probabilistic design. Then one of the first milestones of our paper is let's map what is the research roadmap between the occupant behavior research field and the actual user of the building performance simulations and these models? Because nowadays these models are mainly used by researchers and the developers of the models, but still the practitioners and people that actually is trying to apply the models into building performance simulation is quite limited. So we identify a first fundamental knowledge area where we are advancing a lot, but still we need more standardized protocols and guidelines for conducting and documenting monitoring campaigns, for developing and documenting models, better validation procedures, and then in the simulation front, occupant-centric metrics, exploring different design methodologies, and demonstrating this in real scenarios. Then with this, we can move to an integrated knowledge, where if we have clear all these aspects, then we can understand better what is the scalability and transferability of occupant behavior models from one context to another. What is the guidelines for model selection, and what is the different hierarchy of actions of the different models in a simulation scenario. And then we would need also supporting tools like building performance simulation software that are integrating the occupant behavior models and also helping and guiding the post-processing of these. And with this, the user, the final user of the simulations, then would have the knowledge at a time and effort that is going to be reduced, and then recognize the added value of implementing these models. So we start also identifying which has the added value actually of using advanced occupant behavior models. And first, with the traditional approach, we are only assessing what is the impact of the occupants into the building and the building performance. But for example, with dynamic occupant behavior models, which means that dynamic because they are interacting time step by time step with the simulation software, then you could assess the two-way human building interaction, how the people affect the building, but also how the building is affecting the way the people behave. You could also, with the stochastic models, instead of only having from deterministic models a single value for the performance indicator, you could have the probability distribution or a range for the performance indicator. So you could have a better assessment of the uncertainty and in order to take better decisions. Then also you could test the robustness of your design against occupant behavior. So you could compare different design alternatives and see which one is more robust against the behavior of the people. Then one of the main points here also when you are trying to integrate occupant behavior models is balancing accuracy and complexity. The idea is not to put occupant behavior models in all the aspects of the occupant behavior, but being able to identify which are the most important aspects in each case. This is a case and context specific problem, so you need to do it in within the framework of your simulation. This because occupant behavior is affected by all these different aspects, such as cultural, building use, the context of your problem, the key performance indicators. So you really need to assess this. And for that, you have sensitivity analysis and uncertainty analysis, and we need more screening methods to make this process faster. Then, how can we actually choose the occupant behavior modeling approach? Well, this is again going to depend on the purpose of the simulation, which stage of the building life cycle you are. If you are in an early design stage, you are not going to have enough information to, for example, choose an agent-based model that you really need to all the characteristics of the occupant behavior. Then the same with the key performance indicators, and then this goes together with the spatial and temporal resolution. If you are assessing the annual energy consumption, then maybe you don't need a high complexity model, but you can keep in a low complexity model. The same, the physical destination, so which is the building use, what are the building systems and the control strategies? If it's a passive ventilated building or is have an active HVAC system, all these things are going to affect the choice on the occupant behavior model and the modeling approach. So some main conclusions, we need developing generalized occupant behavior model is virtually impossible. This is because of the complexity of the occupant behavior. Then practitioners could implement occupant behavior models for understanding the diversity of the occupants, how they influence the building performance, assessing different design alternatives. Then we need a fit for purpose approach in order to choose this depending on the case that you are handling. And well, we need databases and tools for identifying occupant behavior models in different contexts. And because of this, becomes highly relevant. For example, the atlas, the Culturally Atlas recently presented. Then thank you so much.
Thank you. So I share my screen. Okay, I think you can see it.
Yes.
Okay, so good morning, everybody, and thank you for joining today. So my name is Lorenza Pistore, and I'm a postdoc research fellow at the University Ca' Foscari of Venice. And today my presentation is on indoor environmental quality aspects, focusing in particular on the thermal environment for plus energy buildings. The presentation is strictly connected with the work of Working Package 5 in the Cultural E project. So just a brief overview of my presentation. In the first part, we will go through the notion of comfort, focusing, as I said, on the thermal environment, and also how to account for diversity driving factors into comfort and well-being. Then we will move to the design inputs gathered from the analysis of existing databases. And after the break, we will sneak a peek into the 2Kappa Energy Atlas. So, I mean, Juan was deeply mentioning it when we talk about the building, we also needed to account for the presence of a user who, as a passive user, is subjected to indoor environmental quality conditions and health issues, but as an active user, he affects the building with his behavior, attitudes, and the controls over the environment. So the user has a very active role than merely being a passive receiver of indoor environmental quality, but we need to take into consideration that the key driver for the user is achieving comfort and convenience. So he's really not very interested in the energy, but he's more interested in services and comfort. So it's very important to understand the different users' attitudes towards the indoor environment, and foremost trying to address the diversities in these interactions. So if we look at the notion of comfort, it has evolved a lot through time and history. And nowadays, we basically ended up with, let me say, a very engineering ideal notion of comfort, which implies in the design of buildings an absence of sensation. We strive to create this indoor environment that never should vary over time or over space. And as Prince said, we try to create this sensationless thermal nirvana. So we usually target in the design, but also I would say also in the standards, very tight and static environments where transition and stimuli are not admitted. We want an absence of perceptible stimuli, kind of imperceptibility of the thermal environment. The standard requires very narrow ranges, equal for all the subjects. So we try to create what in literature are called comfort capsules with this standardized, very ideal format of the indoor environment. But what we are asking in our project is this ideal format really ideal for the users? Actually, if we look at literature, we can see that there is no actual increment in the satisfaction of the building occupants. And moreover, it takes more energy to maintain a very narrow indoor temperature range than a broader range. Moreover, people living in higher indoor environmental quality indoor spaces become kind of, let me say, fussy to the thermal environment. They always have increasingly higher expectations. And the problem with expectations is that they do not have symmetric dynamics. So it's very easy to lift the indoor environmental quality expectations of the user, but it's very difficult then to go back. And this is because we develop a kind of excessive need for comfort, an excessive need for systems and technologies. And it is also due to what in economics it's called the endowment effect. Basically, once we have something, we don't want to go back. And the worst part of it is that also our thermoregulatory system starts to fail in the adaptation. And there are a lot of works focusing on occupants comparing mechanically ventilated versus naturally ventilated buildings. So here I've just tried to sum up a little bit what happens. So basically we have a user with his own sensation and perception, and is striving to achieve comfort. So his key driver is achieving comfort. But of course, the sensation and the perception of the user, as also, Juan was already mentioning, is affected by a lot of aspects. Is affected by his own expectation, his own preference, and his own habituation. But expectation is a very complex sum of different factors, which we could call diversity driving factors. For example, climatic long-term history of a user, cultural and social history and dynamics, demographical, historical and contextual factors, but also educational, and of course, ethnical and physical factors. In order to achieve the comfort, the user adapts. But adaptation in the indoor environment is just not only a matter of the actions of the user, but again, the user is affected by contextual factors or what we could call environmental determinism. So first of all, the building typology. So let's think, for example, that we are at home and we can adapt ourselves as we like because we are in our home. But for example, if we are at the office, we need to take into account that there are other people and everyone with his own sensation. It depends on the controls that we can have within the environment. On the social norms, again, at home, we can stay with a t-shirt and shorts, but in the office, maybe we need to wear a suit, and so it's more difficult to adapt to the thermal environment, but also cultural standards and of course, economical conditions. So yeah, it's clear that comfort expectations and user attitudes, it's just not matter only of an engineering ideal of indoor environment, but it accounts for a lot of different disciplines and also sciences. So in our project, we would like to state that the plus of the building should not just be an energy plus, but it shall be also a plus for indoor environmental quality conditions. So we needed to shift the paradigm into design, accounting for diversities in users' expectations and users' well-being. From literature, we have some hints to do so. We can try to reintegrate these external stimuli with more dynamic environments. We can readmit the air motion within the buildings and thermal gradients. We can target passive design solutions, low energy solutions, and mixed mode buildings. We can try to exploit better seasonal, climatic, and natural rhythms. We could try, I know this is very difficult, but to design the building's configuration and the layout of the building according to the occupant's background in order to encountering for diversities instead of homogenizing the building, to encounter for users' preferences and needs, and last, to empower users with control more than empowering systems. On the user's control, I just want to make a very quick zoom in. So improvement in comfort sometimes is also due to a psychological effect. So the subject's perceived ability to control over the environment sometimes improves the thermal comfort perception. And this improvement is merely due to a psychological effect. So the thermal discomfort of subjects can be reduced even through a slight improvement of thermal conditions with personal control approaches. To do so, it is recommended that occupants are provided with sufficient opportunities to control, even because they like to feel part of a system and not just be subjected to the building. So in Cultural E, we are attempting in addressing diversities in the user's preferences. As we know, unfortunately, standards usually gives us for the indoor environmental quality just an equal value for all the users in all the climatic and geographical areas. But in Cultural E, we're asking ourselves, could there maybe be different values for different users across Europe? So to do this, we are proceeding with the two activities. One is to perform post-occupancy evaluation campaigns, of course, starting from our demo cases, but also in other buildings across Europe. And the second activity is the analysis of existing databases on thermal comfort. Maybe some of you are already familiar with them, but I also put the links here for reference. One is the ASHRAE Thermal Comfort Database, and the other one, on which I will focus today, is the Smart Controls and Thermal Comfort Database. So the Smart Controls and Thermal Comfort Database is a database developed at the end of the 90s for a huge project, led by Nicole and Humphreys for the development of the adaptation algorithm. So we looked at the responses of the users in these databases according to the thermal environment in 5 different countries: France, Greece, Portugal, Sweden, and UK. So we are addressing at the moment 3 climatic areas: the Mediterranean, the Oceanic, and the Subarctic. So what we're basically doing is testing the standard. So we have taken some scenarios from the standard EN 16798 part 1. Maybe you know this standard because it gives us the design inputs for energy calculations according to different ventilation modes, so mechanically versus naturally ventilated buildings, and different seasons, so winter versus summer season. So the first question we have asked is, which is the thermal feeling of a user in a specific country according to the operative temperature design inputs that are given by the standard. So for example, let's look at this scenario given by the standard. We are in summer in mechanically ventilated buildings. We have some prescriptions for the metabolic activity of the user, for the clothing level of the user, relative humidity, and air velocity. Maybe you are familiar with these values if you are, for example, performing simulation. And then we have a recommended operative temperature values for each indoor environmental quality category. So from the worst one, the fourth category, to the first one, the better one. So let's start from the worst category, which is the first category of comfort, where we have an operative temperature recommended of 28 degrees Celsius. And in the plot here, we can see the probabilities of a specific user in a specific country to have a thermal feeling from cool to warm. So let's see how this probability goes. So for example, we can see that in France and Portugal, the major probability for a user is to feel slightly warm and warm with this operative temperature. Of course, in Sweden and UK, the majority of the users will have a probability to feel warm in the indoor environment. But if we look at Greece, we can see that the majority of the user would feel neutral, and the 30% probability is slightly warm. So we can already spot a difference, for example, between Greece and the other countries. If then we decrease the operative temperature to the third category, which is 27 degrees Celsius, we can see that things are moving a little bit. So again, in Greece, we have a major probability for the user to feel neutral in the indoor environment. But for example, in France and Portugal, we still have a great probability of feeling slightly warm, and in Sweden and UK to feel warm. Going to the second category, so 26 degrees Celsius, we can see that in France and Portugal, the user will feel from neutral to slightly warm. But for example, in Greece, it's interesting to see that the user will start to feel slightly cool with 26 degrees Celsius. And this is increasing, going to the first category of comfort with 25.5 degrees Celsius, where we can see that in Greece, it's increasing the percentage of probability of feeling slightly cool. Whereas in the other countries, we still have the users to feel neutral to slightly warm. So this is to show that according to this database, there are actually differences in the thermal feeling of the user according to the same operative temperatures. So we have seen the thermal feeling probability. So now at this point for us, the question was, which is the operative temperature value that maximizes the I'm feeling neutral vote for a user in each country for the scenarios given by the standards, and how this ranges from I'm feeling slightly cool to I'm feeling slightly warm. So let's look at this other scenario given by the standard. Here we are in naturally ventilated buildings, again in summer. And we can see, for example, that if we look at the operative temperature for the thermal neutrality of the user, it's interesting to see, for example, how in Greece this value is up to 27.6 degrees Celsius, but in Sweden we have almost 4 degrees lower, so 23.9 degrees Celsius. So also here it's very easy to spot some differences, and we have the differences also in the thermal range. So we can arrive up to 30 degrees Celsius for a Greek user to feel slightly warm. But in Sweden, this value stops at 26.7 degrees Celsius. But it is important to highlight, and we can see this a lot in some literature works, that thermal neutrality actually does not necessarily mean the thermal preference. So after having spotted the thermal neutrality of a user, we wanted to see which was the operative temperature value that maximizes the vote I want no change in the thermal environment. We took the same scenario to make a comparison, and we can see that, for example, a Greek user would like to have no change at 25.2 degrees Celsius. A Sweden user would like no change at 23 degrees Celsius, and in the middle, for example, we have France with 24.4, we have Portugal and UK, which is very close to Sweden. And it's interesting to compare the values of thermal preference with the values of thermal neutrality, because we can see that they're actually different. So for example, a Greek user would like to have no change at 25.2 degrees Celsius, but it is also the value at which a Greek user would feel slightly cool. So for example, from this analysis, we could say that in summer, in a naturally ventilated building, a Greek user would like to feel slightly cool, and he doesn't want any change in the thermal environment. So I'm sorry if I've run a little bit for reasons of time. These are some first results that we are gathering from our analysis. I just want to stress that these presented results are the outcome of first preliminary analysis with this SCAT database. And so the generalization that we are making are based on this specific sample of observations. And we are trying to propose this new approach in order to account for diversities. So contrarily to the standard that just gives us a unique value for all the climatic areas in Europe, we would like to provide different values across Europe. But of course, these results that we're getting need to be validated with other databases and integrated also with our post-occupancy evaluation campaigns. And in the future, of course, you will find them mapped into the atlas, as we will see later after the break. But I would also like to invite you to keep in touch with the project because they will be also included in our deliverable. So that's all for now from my side. And after the break, we will sneak into the 2-cup energy atlas to see what we can find and what we will find in the future.
Thanks, Lorenza, for this insightful presentation. Let's make a break for 5 minutes and come back at 11:20. Thanks all for your attention. See you in 5 minutes. Hello again. We come back to the next section, which is gonna deal with an interactive exercise. So we will ask all the participants to explore the atlas in a separate window and bring some outcomes from the exploration. But first, before starting 2 exercises regarding occupant behavior and operative temperatures, we will give the floor to Andrea Vianello for presenting briefly the different features that the atlas and how this might be operated. Floor is yours, Andrea.
Okay, thank you, Ivan, for the introduction. Well, hello, everybody. I'm Andrea Vianello from EURAC Research, Senior Technician, and I developed with our team the Plus Energy Building Atlas. Here is the home page of the Atlas. You can read the purpose of the Atlas. And here the 2 group of layers that we collected. You have a description for each one, so you can have a deep look later. And the map that we created, the main map and the analytical maps. If you go here in the menu, you have the 2 maps. So the main one that is here, and you have the description of what you can find inside. You have the structure of the layer panel that can support you in find the most interesting layer for you, where it is in the left panel of the map that now we will see later. And here are some documentation about how to explore the map, the table of contents, and so on. And here, maybe very important, the metadata for each layer that you can find in this structure. So you can just click on it and see the metadata, so responsible, purpose, and license for each layer. And so you can have a deep look also here. Now we will see in few time the main map. Before, let's move to the analytical maps page, where you can find all the list of the maps that we created, where you will find a small cluster of layers with some plots that can support you in the comparison of the layers of the data that you can find inside the layer. And so you can just from this page click and see the map and play a bit with the layers and the data and the plots that you can find. Finally, here in this page, you can find our contacts. So all the team that worked on the development of the atlas. So Lorenza, Ivan, me, and all the team, the project manager, and so on. You can write us an email to all of us clicking just here, or to just one of us for specific question. Let's move now to the map. If you click this button, you have access to the main map that is here. As I told you, here you have also a button where you can quickly visualize the left panel in order to have some support in finding your layer. So it depends if you're interested in climatic factor, just move to the group number 3. If you're interested in the energy cultures layer, move to the group 8. So how work the left panel? You have many groups that are represented with the icon of this folder. You can collapse the group if you're not interested, just to move easily in the group that are lower. And for each group, you can decide which layer you want to visualize. So initially, when you load the page, the first layer is switch on. And if you click in this icon in the group layer, you will switch on all the layer of the group number 1. And here you can zoom and you can click to get the information collected in the layer. So for example, if we click here, now all the layers are loading. And then if you click here, in the right window, you have a pop-up that shows you all the information that are collected in this layer, that are 1, 2, 3, 4, 5 layers. So what happens when you click, you get the information about all these 5 layers. But have a look here in the title of the layer that you are watching. So here you get information for the Germany country, for the lighting and appliances. And if you use this arrow, you can move to the other layer that are switch on. So here you have the household cooking practice, here the water heating, and here the household space cooling, and so on. Pay attention that if you highlight one layer, even if there are others that are on, when you click, you will get information only to that specific layer. So this may help you for getting information about your layer, but may give you some confusion. So just pay attention if you highlight some layers. Okay. So now if you want to see other layer, you can easily click here in the group layer. You can switch off everything. If you scroll down, for example, we can move to the layer that Ivan presented here. zoom a bit out, and here you get the information of the layer. So what happened when you click in a specific country? You get all the publications that are in this region, in the area where you click. So here now we have all the information for Germany. You can scroll down and you see the publication for the specific country. If you click in this polygon, let's have a look also to the legend. You can see that the gray area are the NAS2 level. So if you click in a NAS2 level area, you can find the information both related to NAS0, so all Germany, or only to the specific NAS2 level. Okay, so here you get the first one that is NAS0. If you scroll down, you will see other NAS0, but also the NAS2 level publication that we collected. I will show you briefly also the layers of Lorenza that are here in the 4 indoor environmental quality aspects. The 4B group has 4 layers, so you can switch on all the 4 layers at the same time, and then when you click, you will get information regarding all the 4 layers. So if, for example, we click the France, we have the same information that Lorenza showed to you before. And then you can read here, for example, we are watching the mechanical ventilated building. And then you can move in the same way than before to the other layer. So mechanical ventilated buildings in winter, natural ventilated in winter, and natural ventilated in summer, and so on. Scroll down, just pay attention here that we have, unfortunately, many scrolling bar that make some confusion. So just pay attention that you can see all the information that there are in the pop-up window. Last thing that I want to show you that may be useful for the layer of Ivan is that when you click in whatever region, here you have a link if you want to use an additional tool for filtering the information, also filtering the publication that you get. So if you click here, you will open an additional map, a new map that just contains only 1 layer. So only the occupant behavior modeling. If you highlight the layer, you have here this tool that is the attribute table. And it is very useful if you want to filter the publication. Let's make an example. Here you have all the attributes that are collected in the layer. And if, for example, you are interested only in some publication for some specific year, you can, for example, write 2018, and all the feature will be filtered, and you will see only the publication in 2018. Or, for example, let's make another example. If you want to see only a specific country, you can just write, for example, the first letter of Switzerland, and you will see only the Switzerland, and so on. Maybe also useful here in the right, you have the building use, so you have to read here in the attribute 17, where you have different building types, so office building, residential building, and so on. So here, for example, you can write office or just the first letter, and you will see only the publication for this type of building. So just click in one of it, and you will get the information regarding the office building. I guess that's all. I hope you can understand how it works. So I give the floor to Ivan to continue the exercise.
Thanks, Andrea. Hopefully it has been clear for everyone, this comprehensive explanation of the different features and how the atlas works. So now I'm going to ask everyone who feel like to turn on the cameras and initiate first exploration of the map. I'm going to share my screen again with few slides. So as described in the agenda, we have prepared some questions that we are going to post in a specific dedicated poll for collecting your feedback, and we are going to run 2 exercises. One is related to the last layer that has been commented by Andrea, the occupant's behavior modeling layer. But first, I'm going to ask you to locate a theoretical location for a building project where you will be focusing your exploration, and do in the next few minutes some testing on the different layers that are available for checking the insights and the information that is provided. Then after this, my proposal is to go to the last layer of the atlas and to check all the available OPA models that are sourced into this layer. And if you would like to make a more accurate searching, you can use the last tool feature that Andrea was describing, and try to identify by the attribute corresponding to occupant action and presence the different uses that can be analyzed or are analyzed under the literature review, and then trying to figure out if the information that is sourced could be useful for your practices. So I would like to ask all to go and exploring the atlas in the next minutes and pose any questions that you may have. Did you have any troubles for exploring the atlas? Did you check it before the beginning of the workshop? This is kind of an interactive exercise. We will be happy if you can comment.
There is one comment in the chat from Karun. It's a very user-friendly. I don't know if you would like to elaborate more, or if you're a little bit shy. Linda is asking, can you share the screen, the link? Yes, I shared it above the chat. I can share it again.
Yes.
Thanks, Lorenza. Lorenza is also sharing the link. There is one question from Veronica. I don't know if you would like to say it out loud, to turn on your microphone and camera to start the debate, please.
Yes, Veronica is asking about the data which are corresponding to the different information that is provided. Some layers are containing information from 2018 when we initiated the first configurations, and this is going to be updated by the final version with the most recent studies. For the statistical data, we are sourced mainly by Eurostat, and this is a yearly basis update. So we are on progress on doing the updates year by year. And for the other layers that are referring to more criteria for PEV design, and these are not linked to a specific dates, and even so, we are also referring to the date of publications. So you can even do the filtering through that feature. So that was my first proposal for you to explore the map, to go to the last layer, to check in your country which are the available publications, and then going to the filtering tool to identify how many of them are referring to the different uses. So please try to play a little with the tool and provide your feedbacks by the last part of the workshop on the open discussion. Now Lorenza, maybe she wants to continue with her proposal activity for the indoor environmental quality aspects. And before jumping to the Italian experience, Gloria is going to pose a poll for you to provide some feedbacks. Lorenza.
Yeah, I'll just go very quickly to the layers connected to the indoor environmental quality aspects. Maybe there is before a question for you, Ivan, if you want to answer before I start.
Yes. Linda is asking if we can say again where we find information regarding Windows opening practices. Yes, I'm gonna share my screen. I'll go to the map. One second, I'm going to share directly the atlas. So now we have closed all the different groups, and we are only exploring the last layer, which is the occupant behavior, which is turned on. And this allow users to click in the different locations and to get the different information which is available. As Andrea was commenting, we have merged here two granularities, national and regional level. In the regional, we can find both the national and the regional according to the specific location. And in the bottom of each entry, which provide information on the authors, years, occupant presence, city, country, climate zone, building use, and the outputs from the research and the models used, as well as the DOI or reference code for the publication. And then there is a tool that brings you to the same map, but in the EURAC platform. This is a feature that need to do further improvements in order to allow integrating in the website these other features that are available in the normal map. But we struggle to make these functions appearing in the embedded window. Then we decided to create this alternative way of reaching this source. And here in the open attribute table, you will get all the entries regarding the layer, and you can scroll until the one that is referring to the occupant presence of actions, and here is the different attributes. So we can just click window, and it will appear in the map the different locations where there is a studies referring to windows opening. As we can see, there is no anyone that is referring to a national level, but we have several ones in different locations, which can be useful for assessing how this can be complementary to the studies, despite your location might not be corresponding to the area where there are information available. If we are in a continental climate, it might be useful to explore the available ones in Germany. If we are in the oceanic climate, the availables in UK could be useful. Also, we have some information in the subarctic climate in Denmark and Norway. And in Italy also there is some, and Greece, there is also some information available. So hopefully this can answer the question of Linda. I stop sharing and I give you the floor, Lorenza, to briefly comment, and in few minutes, Cristian and Riccardo will continue with the presentation of the experience in Italy.
Yes, thank you, Ivan. So according to, referring to the indoor environmental quality aspects, what can you find within the atlas? So at the moment, as Andrea was already mentioning, we have two groups. We have the environmental parameters and we have the thermal feeling of users related to the operative temperature. So what I've shown to you before. This latter layer has just been implemented in the final period. The working package that is working on this aspect is still running and will be running until the end of the project. So stay tuned because there will be a lot of integrations and additional information. And so in the future, there will be two additional layers about the thermal neutrality of the user and the thermal preferences of the users. And finally, one layer gathering all the information that we will spot with the post-occupancy evaluations in our buildings. So I will go very quickly, then we will move to the atlas. So in the layer environmental parameters, basically you can find specific data sets referred in this moment to the closest locations to our cultural demo cases. So in each location, you can find gathered together some data inputs and graphics that we have collected with other tools and sources. So you will find a reference here, weather style, which can be useful for your simulation campaigns, statistical data about climate and weather in the locations, weather data plots that we have elaborated by ourselves with a specific tool, and weather data summary. Of course, as I will show you, you can find all the references provided for the data source and the tools that we have used to implement this kind of information. As I said, then there is a layer about the thermal feeling. And in the future, we will have the layer about thermal neutrality, thermal preferences, and the post-occupancy evaluations. So basically, in these layers, you will find a prediction of the occupant's thermal feeling, thermal neutrality, and thermal preferences in the different specific climatic areas, according and starting, let's say, to 4 scenarios recommended in the standard EN 16798. As I said, these are preliminary statistical analysis that will be integrated over time. So moving quick into the atlas. So as Andrea has shown to you, there are multiple layers. So we are number 4 in the environmental quality aspects. So if you open this group, you will find the environmental parameters and the thermal feeling according to the operative temperature. So if we look at this one, as you can see, we have the locations of our 4 demo cases. So let's just open one to sneak a little bit into it. You can find available for download all the files that I've mentioned before. As I said, they have been elaborated with other tools and we gather data from other sources. For example, the reference here, I think you are already familiar with the file from Energy Plus. And of course, all the references are stated here below. And what is interested, for example, is this file with the weather data plots, which have been elaborated with the climate consultant, which is a tool. If you're not already familiar with it, I really suggest to you to take a look at it. It's a tool provided by UCLA, and it helps you to analyze the climatic data of your location, the indoor environmental quality conditions of your building in order to target the design of the building. So this is an example of what you can take, and this is all included in the atlas for easiness. So you can just download the file. You have the plots of the weather and climatic data, like the temperature range during the year, the monthly averages, the radiation range, the sky cover range for that location. But also there are interesting sun shading charts with which you can play, for example, to design correctly your shadings in the building in order to target the comfort of the users. Wind velocity, and a very interesting thing you can do with this tool is, for example, according to the psychrometric chart, and so in order to achieve the comfortable conditions, it gives some design strategies for your building to achieve comfort, and most of them are passive design strategies. So it could be very interesting to have a look at it. And this was one of the layers. In the second group, which is the thermal sealing, so you can see, as Andrea was showing, the 4 different scenarios given by the standard. So if we click, for example, on this one, and we took a reference country, which are the one striped, sorry, you can find, let me close a little bit. Okay, for example, you can find what I've shown before about all the different scenarios. So for example, this is mechanically ventilated buildings in summer. These are the inputs taken from the standards and the recommended operative temperature, and you can find the results that I've shown before. So this is what we have up to now. As I said, the configuration is in progress, so there will be a lot of integration in the further period, which we hope can be of help to better target your simulations and your building design according to the different preferences of different users in different climatic areas. So this is basically the aim. And yeah,
we have prepared a few questions, but yeah. As we are on a little delay, I'm going to recommend to reschedule the questions and then now giving the floor to Cristian and Riccardo for commenting their work on the demo building in Italy in the Mediterranean climate, and then in the final discussions that potentially will run 10 minutes after the expected end of the workshop, we will have the chance of answering the poll questions. So Cristian, floor is yours.
Morning to all. I will go very quickly through some slides that we prepared to describe what ABIT-COP, which is the demo owner, has been doing so far in the Italian demonstration building. And then my colleague Riccardo Pinotti will introduce you how simulation could help along this process. So ABIT-COP is a company that mainly targets social housing, and among their values there is solidity, reliability, but also innovation. And they are doing and have homes and this is the first experiment on positive energy houses, but their approach is to follow their members also along the building life cycle. So as I mentioned, they take care also of what happens next. They provide these houses for ownership, use, or rent. And they also provide assistance, and they follow also their members what concerns their living conditions. As mentioned before, there are 4 demo cases. The Italian demo case is related to the Mediterranean climate. And what is important is that these clusters differs from climatic context, so temperature, weather, and also the latitude, so the sun orientation, for example, or the available power for the photovoltaic. And also cultural context, such as user behavior, as we discussed this morning, habits, preferences. So everything about this, especially for this new type of houses, needs to be considered since the early stages of the design process. And we need to keep an eye at the value, the final value, and also the costs, investment costs, and operating costs. As an example, I'll go through very quickly through this. These are 2 scenarios in which the user appliances impacts differently, the space heating impacts differently across 2 clusters. These data are old, but in the atlas we can see fresh data on this. We need to consider that, because in this type of buildings, the share of energy spent for heating and cooling is not so high compared to the plug loads, for example, to energy for the user. And this means that if we target the positive energy balance, we need to weight also the user and to consider what the user is willing to do. So HabitCorp focuses on indoor environmental quality, the building value, climatic resilience, and also environmental impact, but also the positive energy balance and life cycle costs that are the main target for this project. The demo includes 2 pilots building. The building A has 7 apartments and 4 floors. The pilot B has 6 apartments and 3 floors. The average size of the apartments is ranging from 75 to 110 square meters. There are garages at ground level, a common garden, and the target is the mid-class, so singles, families, and elderly people. Here I show you some renders so that it's more clear the shape and why. Of course, they put photovoltaic over the two different roofs on 2 different levels, and also the shape, the area of the roof was defined already at the early stage, and we will see later. It was important to check at which extent they could reduce the energy consumption, and therefore if the roof was large enough to host the photovoltaic system. There is also a reference building, which is an NZAP building, certified by Casa Clima Class A, which is used in the project for reference. So the costs and the energy performance and also the user behavior we will monitor also in these 3 buildings to check what is the difference from NZEB to PEB building. These pilots embed different technologies, not only insulation layers, but also the active window system. They opted for this packet heat pump, which provides heating for the underfloor heating. It has also a thermal storage embedded. It provides air cooling, which in Mediterranean climate is very important. And it also integrates phase change materials for the thermal storage, so it's a bit particular how it works. It also manages to produce domestic hot water. The ventilation as well from this machine, and the ventilation is then controlled based on local conditions, temperature, humidity, CO2. They have put some sensors there. Lighting is standard by LED, and energy production from the roof is coming from photovoltaic on the roof. There is also an electric storage and a BMS, a particular BMS that can control all these technologies together and also accounts for the user behavior. There are also special fans for moving the air around the users, so that in this way some energy for cooling can be saved, and also shading systems. There are some challenges. Basically, the heating and cooling capacity is limited, and on the other side, the units are highly performing. But from the design, it is clear that they need to avoid peaks in the demand, and it is a good approach to overlap the air movement and the cooling, depending on the temperature of the rooms. There is a need for advanced control logics to be adopted there, and taking into account the user occupancy, the behavior, the preferences, and the energy flexibility is a good opportunity, as here there are electric and thermal storages to be managed. And then an important aspect is that the resources are limited. In particular, the roof area is anyway limited. So it is important to know from the beginning of the design how to reduce the energy consumption properly. About the timeline, we are now at starting the building process, and dwellings we will deliver in the first quarter of 2023. And then there will be a monitoring phase to check that everything was done correctly. Here I put this slide to mention that there are a lot of tools that have been used and can be used for to support the design process. To get to the preliminary design, for example, it was important to understand the feasibility and the cost, more or less, for the photovoltaic system on the roof, and then to get to the final design, an optimization of the photovoltaic, also including the sizing of the batteries, was performed. So different levels of different depth of information. Dynamic thermal simulation was an important tool because it was important to understand the energy consumption for heating, and then to check if the cooling capacity was enough. There are, of course, mandatory compliance tools to be used. We will see later not always with this new type of buildings, these tools are providing correct numbers, so we need to consider this. And then, of course, the LCA, so the impact, environmental impact, and the cost impact on cost, not only the investment, but also the operative costs should be considered. And finally, all these tools could be used at some extent from the beginning, then to the across the design phases down to the final design, and now after the procurement, there will be the assessment by the monitoring. So I leave the floor to my colleague Riccardo.
Yeah, so good morning by my side. We'll try to be very quick, and I will ask you, Cristian, to switch the slides. So just to show you briefly how simulation activity can help in these preliminary stages. Especially, we applied dynamic energy simulations to the Italian demo, and of course, this simulation activity perfectly fits with the input provided by the atlas. So actually, this is what we input in the software. We use transits to perform these dynamic simulations. So you just can see here the input. So for the set point for heating and cooling, 2 fixed set points. Then we perform some parametric simulation in this case. So you will see different inputs too. So for instance, the presence of the mechanical ventilation with a certain air change rate and a heat recovery. Then the infiltration rate was fixed, and then instead we parameterized the type of windows, so double and triple glazing, and also we made parametric the presence of the shading system and its control logic. So from the absence of the shading system passing through a basic control just based on radiation, and then also including the effects of indoor and outdoor temperature. Then the presence of the smart ceiling fan, so the technology Cristian mentioned before. And then in the demo, we were interested in defining the effects of different insulation thickness and material. So yeah, the next slide, please. Okay, this is just the model of the building, 3D model. We used in transits with 2 zones per apartment, so night zone and daylight zone. So next, yeah, one before. Yeah, so this is all the dots you will see in this graph are all the simulations we did. On the axis, you see the heating and cooling demand, and you see the effect of the different technology I mentioned before. For instance, I don't know, the blue squares, the blue rectangular shapes are indicating the effect of having or not the shadings, and the effect of having a specific control on them. I don't know, then the effect of the smart ceiling fan. So in this group of simulations, you see that the one, of course, with slightly less cooling demand are those where the ceiling fan is used. And then the effect of the thickness and insulation typology, and also, yeah, of course, as I said, the different type of glazings. So from all these, let's say, picture of simulation, a focus were made on one of the most, let's say, promising one. And then if you go on the next slide, so that's where we focused our attention to reach the positive energy building target. And so this simulation had an advanced control for shading system, a triple glazing, the presence of the smart ceiling fan, and this type of so the thickness of the wall of 30 centimeters using APS as insulation. So in the next slide, you see in the coldest, and then in the slide after, the hottest week that we used in order to have an indication on the peak of the heating and cooling system we needed. Here I just reported the amount of power needed, of energy needed by the smart ceiling fan, differentiated by the apartments, and here again the cumulative energy. So okay, this is quite interesting because I just reported the comparison between the results from a steady state simulation, steady state evaluation of the consumption of the building done using the legge 10 regulation, let's say. And then in the bottom part, the results from our dynamic analysis. And just if you compare the the circles, so where the color is the same, let's say, amount, you see huge differences. Just as an example, the first circle, the blue one, is the irradiation, and you see that using a dynamic simulation, which is exploiting a weather file, so all the data at each time step of a weather file, you see that the irradiation is almost doubled. So of course, you having this kind of modeling helps having much more detailed results. So please, next one. Yeah, another very interesting work which we have done was an optimization of the PV panel placement on the building, and of course this is let's say mandatory stuff almost to reach the target. And so we performed some simulation where we define specific places to put the PV, for instance, on the roof and on the facade. And the optimization was targeting at reducing the payback time within the 50 years after the investment. And so here we made some consideration accounting the production of PV to the whole building, and then in the next slides, instead of accounting of sharing the whole production to the whole building, we split it into different flats. So starting, of course, from the consumption cures for each flat, an optimization of the PV was done. And also considering the last slide I have, also considering the effects of having different size for the battery. So yeah, basically it was very quick. We didn't go through the results, but just to let you know the power of this kind of instruments and how this can be really coupled with the inputs from the atlas we are developing. So that's it. Thank you.
Thank you very much, Riccardo and Cristian, for this complete overview of the process for the Italian demo. And we will continue updating the further developments on simulation and how the Atlas is inputting on this process, potentially by the middle of 2022, when we will be carrying out the midterm conference of Culturali. Now I may invite all participants to turn on the camera, so we are gonna start the discussion. It's gonna run during only 10 minutes as we are on slightly delay. We were very optimistic with the agenda we ran it, and starting by myself that I took a few more minutes. We have run a little longer from the provisions. Any first comments from participants before we launch a few questions for opening the debate? So maybe we can initiate by launching the poll that was prepared, aiming to get your feedback on the tool. Gloria, could you just place the various tools, the various questions, please?
Okay, so I kindly ask you to grab your phone or open a browser page on your laptop. We're going to use Slido, so you can go to slide.do and you can insert this code. I'll leave you a few seconds to do that. Otherwise, if you have, if you're going to use your mobile device or your phone, there is you can scan a QR code in the next slide. So there it is. So, or you go to the website and you write this code, or otherwise you scan this QR code and you are inside the poll. Hope it's clear enough. So just to have a test question, where are you based now? Please write it. It's an open text question. Italy, UK, Italy, Northern France, Espoo, Finland. Hi. UK. Okay. So Slido is working. Nice to see that. Which sector do you work in? Higher education. Okay. Social housing. Interesting. Research course. You can also select an option that is already there. So the more you are, the bigger the word is. So research, it's like already, I don't know, at least 3-4 answers. Consulting. Academia, research. Okay. Next. Next poll, are you experienced with the design of plus energy buildings? Yes, totally. Yes, partially. No. Yes, partially. That's a nice data. 62%, 67%.
The next 3-4 questions are referring to indoor environmental quality aspects. So keep in mind this when answering, please.
Yeah, these questions were prepared, Lorenza. I don't know if you want to comment on that, please.
Yeah, I just wanted to know your thoughts. And so first of all, when you, for your design activity and energy calculations, if you use an European standard, like the one we are addressing, or if you have some national standards that you take into consideration, or other sources.
Okay, let's go on.
Yeah, and this was basically why I was asking that. So because I wanted to know if your source does account for diversity driving factors. So for example, I expected that maybe a national standard takes into account maybe more specific factors, whether maybe, as we have seen, the European standard has a unique value usually for all geographical areas.
Okay.
Maybe we can move.
Next question.
So again, this is more related in the specific to thermal comfort. And so if the standards account for adaptation mechanisms of the user within the building and the other contextual factors related to the building typology, for example. So if we are in different buildings or how the user can adapt within the building. And we can move, I think.
Yes.
Yeah, this is more related to your activity. So today we have seen that that there could be some differences among users in different areas. And this is based on analysis of databases. But I wanted to know if you, in your practice, have ever noticed a gap between the values given from a standard and what actually people in your country would like to have in their indoor environments.
Well, 100%. Yes.
So we're doing the right job here.
Yeah.
And yeah, here it's just an open question. So especially if you said that it's a national standard, it's interesting to know which standard it is, because maybe it could be of help for us to spot the more specific values related to geographical areas or countries. So if you want to share with us, feel free. Okay, I can see there is a bit of heterogeneity, so good to know. Maybe then we can comment a little bit if we have time. We can move with the other question now.
Yes, Ivan?
Yes. Now a couple of questions regarding the simulation practices. How do you believe, or how do you think that PV design can integrate and react upon the energy trade-off in front of end users' daily practices on comfort, cleanliness, and convenient basis? So how we can tackle the gap? This is a question with only one option, but it may allow potentially to various answers. It's interesting to see that your opinion are more referring to user-centric approaches, and modeling is partially highlighted as an important approach. Next question, please. And here we refer to the tools and methods that are in force and that you practice eventually, and if there is any gap between the capabilities that the tools bring and the required inputs for getting a successful PV. interesting to appreciate that most of the tools that you are using do not allow do not provide outputs according to user perception and behavior, and some of them they not allow the integration of a specific occupant behavior models. So we are somehow trying to tackle these circumstances throughout the atlas provision and information we are tackling. So thanks. I think this is the last question of the poll. And now just 5 minutes of discussion, and I invite all participants to provide feedbacks. Maybe we can open that discussion with the question that was proposed yesterday by the presenters. Do you want to read them, Gloria?
Okay, so are there tentative standard procedures to guide the OPA models selection for simulation-aided design according to building context specificity? You can try to write it down in the chat if you want.
Okay. Maybe this question can be partially answered by one of the slides that Juan was commenting on the complex process that now is not standardized, but your approaches for getting closer to it.
Yeah, exactly. I think that there are not really proper guidelines or standards, but we should move in that direction anyway. Like address this as a urgent matter in order to effectively integrate occupant behavior models.
Throughout the Atlas provision, we are partially going in that direction by providing more accurate functions that allow designers to identify available OPA models in specific countries and climates, and also according to the different actions and presence. Not all the papers and study data refers in that database could be integrated in all specific projects, but we invite users to assess the available research conducted and try to merge, when possible, the existing OPA models. And a last question that was posed yesterday.
Yeah, there is a question for Cristian. While positive energy balance is fundamental, which other aspects should the building developer or the designer consider? Cristian, are you there? Yes.
Yeah. Yeah, sure. There are other aspects to be considered, in particular, all related to the sustainability in some sense. I mean, from the economic point of view, but also in the life cycle of the building. So we should consider how the design that we have in mind will perform under the investment costs, but also in the operative phase. So which will be the running costs to keep it performing as a positive energy building. And then also the social impacts are important to consider. The sustainability towards, for example, the interaction with the power grid. So the building should be nice enough, appearing as a flat load, basically, towards the grid, and also the energy that is produced locally should be consumed also locally. So just to avoid the congestion on the network and to use it, the energy at best. There are, of course, the environmental impact, so the greenhouse gases emissions reduction mainly is very important to look at since the early stages, because of course the energy consumption is important metric to consider, and all these aspects are of course not telling you anything about energy balance, of course, but what it's important to say is that the first goal is to reduce consumption and environmental impact, and then to cover all the remaining part by generation of power and energy by renewable energy sources. So this is the main point of view, and the costs should be somehow under control from the beginning.
Thank Cristian for this detailed overview of the different factors to account when designing.
If I may add something,
please.
Since it's a huge objective of our project, and there is a task entirely dedicated to it, is that we are also considering the co-benefits related to plus energy buildings. So not only the direct effects like energy consumptions, CO2 emissions, and then costs, of course, but also the co-benefits related to households and the community levels. So indoor environmental quality, but also climate change and society aspects and so on. And we are trying to quantify them, so to include also these aspects in the balance and in the business model for these buildings.
This piece of work will be also introduced, integrated into the atlas properly when the task will end up, and we will be able to show guidelines on the co-benefits and co-impacts topic for positive energy buildings. I may also comment that in order to decrease the gap, the performance gap for between design and performance, we need, of course, to have a common strategy for the simulations in the 4 demos that we are now putting all these pieces together and bringing common conclusions from the 4 different climates and approaches, and this may be helpful for analyzing after with all the post-occupancy and monitoring where the best approach or the most accurate approach for simulation is allowing to reduce or mitigate the gap. Then the project aims to contribute to this piece of research where all the complexity of the building design is integrating occupant behaviors. Thank you so much for your time and for staying half an hour more than it was expected in the meeting. I really apologize for the fact that we ran finally the event on an online format. This was expected to be conducted in person last January in simultaneous to the Climate House conference in Bolzano, but unfortunately due to the COVID circumstances, we have been forced to run it online. So sorry again for this complication complexity of running an interactive workshop where we ask for your contributions in this hard scenario of the online platforms. But we really thanks your participation and your contribution, and we hope that this tool and the work that we are developing in Culturally is somehow bringing the gap between research and practice, and we will be able to continue working together in the next sessions and seminars.
Thank you to all the speakers for being here. Thank you.
Thank you all.
Thank you. Bye, everyone.
Thank you all.